So good evening everyone, and welcome to week 3 of this DSA training session. Uh, Today we'll be covering arrays and strings along with string functions. I'll be covering the string part, and Rajesh from CST second year will be covering the arrays part. And I think Rajesh can start now.
Yes, hello, good evening, everybody. Let's start. You can see my screen, right?
Yes, your screen is visible.
Okay, fine. So, welcome to this session. Uh, now, let's discover about these arrays. So, why an array? Let's consider a situation where we need to store the 100 students' marks. Uh, we want to store it for some calculation or maybe some manipulations. Then, how do you store it? Uh, how do you say? I mean, since marks is an integer type, we can store it something like below, like marks 1, marks 2, marks 3, and so on. Marks 100, that means using 100 variables. Is this the good way to store it? Uh, we have a better option. If we declare like this above, it will be very difficult for us to manipulate the data, and also even the number grows. It is very difficult to create a lot of variables like this. Marks 99 gives the marks of 100 student, and also marks 5 gives the marks of 6 student, and so on. Now let's see the definition of an array. An array is a collection of variables which is of same data type. That means we can't store the elements of different data types in a same array. Like if we want to store two elements from integers and two elements from float and one element from character, it is not possible. All the elements should be integer, or all the elements should be character, or all they should be float. Hence, the array is called a homogeneous data structure or homogeneous data type. Homogeneous means all are of same data type. So let's see how we can declare and initialize an array. In this way, we can declare an array. First, we need to mention the data type of it, like integer, character, or float. And then we need to give the name of it, and then the size of it, how many elements we need to store. For example, here int ARR 100, int is the data type, ARR is the name of the array, and 100 is the size. We can also initialize the arrays like this. ARR, here I am not specifying the size because I'm already giving the elements. So the compiler itself understood that the size is 4. This is of character type. I may or may not give the size. And now let's talk about index. How we can access the array elements? The answer to this is by using an index value. We can directly access the desired element in the array by using the index. The array index starts from 0 to n minus 1, not from the 1. I mean, the first element will have index 0, the second element will have an index of 1, and so on. The last element will have a size of, I mean, the index of n minus 1 if the total number of elements is n. So to access the first element, we can directly use index 0. To access the fifth element, we can directly use index 4. We can manipulate the nth element by using the index n minus 1. And obviously, the n should be greater than 0 because the array should minimum have one element. The size 0 array is not possible. So this is a pictorial representation, or this image where we can see how the array elements are stored. These array elements are stored continuously as ALR0, ALR1, ALR2, 3, and 4. Here I took an example which consists of 5 elements. So let's see how we can take input and output of array. Till this it's clear, right? Or anything? Any question?
You all can like unmute and ask if there is any doubt or anything.
Okay. So
Okay, I think it's okay.
yeah, let's continue. So let's see how we can take input and output. This is a C++ program. So first I'm asking the user to enter the size, enter the number of elements. This is one of the disadvantages of array. Like we need to specify the size before, and I'm storing it in variable n, and then creating an array of size n, and I'm taking the input of all the elements by using this for loop and storing it in array, and just I'm printing this is the output. Again, I'm using for loop for it, and at last the end line. So this is how we can take input and output arrays. So let's take one example, finding the average of a data by using arrays, how we can do that. So first this n is for size, and again asking user to enter the size, and then storing it in n, and creating the array with size n, and then asking user to enter the elements. Again, by using the for loop, we are storing it in the individual, the element. Average is the sum of elements by the total number of elements. So we need to find the sum of all the elements in the array. For it, uh, for that I'm creating a variable sum. Initially it is 0. I'm iterating to the array and adding every element of the array to the sum. So sum plus is equal to ai means I'm adding sum. I'm adding ai to the sum, and then the average sum by n. Why I'm typecasting to float is because by default the division in C++ is a float division. So I'm typecasting and then printing this average, return 0. So this example of an array, how we can use arrays. So let's see one question from the class. Okay, given an integer array nums. So we are given an array. The name of the array is nums. Its length is n, and we need to create an array of length 2n, the double of this size, where answer I is num size and answer I plus 1 is num size. Okay. Actually, the question is answer is the concatenation of the two num arrays. Okay, that means we need to add the two num arrays side by side, and that is the answer. So sample input and output is a 1 to 1 and 1 to 1, 1 to 1. This is how we can form that array. I think you understood the question. Now, this is the solution for it. I'm taking my own array, but in the question, you can take it from user also. As the size is 5, so I'm creating the answer with 2 into 5 size. That means 10. And by using this for loop, answer I is equal to num size and answer I plus 5. Here 5 is the size, or you can say it as n equal to num size. Uh, Now our answer is ready, so I'm printing it. Okay, is this question clear? I think no questions. So now let's talk about the multi-dimensional arrays. Till now we talked about single dimension. Now let's talk about multi-dimension. What is a multi-dimensional array? Simply we can say an array of array. Okay, in simple words, the multi-dimensional array is an array of arrays. Data in multidimensional arrays are stored in tabular form in row measure order. Okay, what is a row measure order? Let's talk about it later. But uh, this is an example of a multidimensional array. see here, this is one array, this is one array, this is one array. Now these three arrays are stored in another array. So this is an array of array. Now this is the like if you can understand the like in matrices, it is like 1 2 3 4 and 5 6. So how many rows it has? It has 3 rows, and also it has 2 columns, right? So this first dimension is the number of rows, and the second dimension is the number of columns. Okay. So this is a visual, I mean, pictorial representation of a two-dimensional array. Suppose I have an multi-dimensional array float. Name of the array is x, and its number of rows is 3, and number of columns is 4. How the elements are stored? This is the row 1, x00. Uh, as we talked about it before, the index starts from 0, not 1. So the number of rows starts from 0 to m minus 1 if we consider m is the total number of rows, and also columns index starts from 0 to n minus 1, right? So this is x00. This is the first element, or if you talk about in matrices, x11, and this is x12. By index is 0 1, and so on. uh, what about third three-dimension matrices? I mean, suppose I want to create three-dimensional array, so that looks like this. Now this part we can understand, right? It is the number of rows, so 2 rows, and this is the number of columns, so 2 cross 3. Now these 2 cross 3 arrays are uh, over there. This is how we can understand the three-dimensional array, right? Like the third dimension, suppose x y z are the three dimension, then there are z number of two-dimensional arrays are there, a x y. Okay. So here this number of rows are 2, columns are 3, and the number of two-dimensional arrays are 4. So total number of elements are 24. Okay. Is this clear? Now let's look at an example how we can use the multi-dimensional arrays, the matrices addition. This is a program. Uh, First, I am taking the number of rows, number of columns, or the first dimension and second dimension of the array from the user, storing it in M and then creating three arrays. First one is to store the first matrix, second one is to store the second matrix, and the third one is for resultant. For int I is equal to 0 to m, that means till the number of rows. I mean, this for loop works the number of times that is equal to the rows, and this for loop for columns. And first I am initializing with 0 values. This we can do or may not do. This is optional because initially when we create, all these arrays contains the garbage values, and we are overwriting them by our own values. Okay. So taking the input of the first matrix by using the two for loops, again the second matrix, and adding them. Cij is equal to aij plus bij, and printing the resultant matrix, again by using two for loops. Now let's solve a question which is which is from multi-dimensional arrays. Let's read the question. You are given an m cross and integer grid accounts where accounts ij is the amount of money that the ith customer has in the jth bank. Return the wealth that the richest customer has. So what the question is saying is, we are given two-dimensional array accounts. The name of that two-dimensional array is accounts. It has certain number of rows and certain number of columns. Each row represent a customer, and each column represents a bank. Now, suppose let's take it like this. For example, now this is the customer one money in this first bank or the bank A, and this is the money of first customer in bank B, and the money of customer 1 in bank C. Similarly, this is for customer 2 and this is for customer 3. This is how that accounts two-dimensional matrix represents. Now, what we are asked, uh, the richest customer, I mean, return the wealth that the richest customer has. A customer's wealth is the amount of money that have in all their bank accounts. The richest customer is the customer with the maximum wealth. So what is the wealth of first customer here? 1 plus 2 plus 3, that's equal to 6, and this is equal to 15, and this is equal to 8 plus 7, 15, and this is 24. So this is the maximum. I took it randomly. So here is an example. This is the first customer wealth, money in all the banks, and this is the second. It first customer has total of 6 and second also 6. The answer is also 6 because the money is also 6. Uh, Now let's see the program. Here also my own values. We can take it from user also. And for calculating the maximum, I am declaring a variable answer, which is storing very least value because I need to override this with the first customer wealth. Okay, from I is equal to 0 to I less than 2. Here instead of 2, if you take it from user, this number of rows will be there. And here calculating the total of each customer. Okay, for this variable. And here instead of 3, there will be n, that is the number of columns. And for each customer, I am calculating all the money. Total is equal to total plus accounts IZ. Okay, now after complete completion of this for loop, this total has the money total money of ith customer. And if the total is greater than answer, now answer becomes total. Okay, and then at the last, I am printing this answer. Is this understood this question? Any problem here or any questions? Okay, let's move it to. Now let's see how to calculate the address of each element in one dimensional arrays. Like we discussed, suppose there is an array A of size 5, how that will be stored in memory? That will be stored in memory as contiguous blocks. So first this is A1, and right after it A2, and then, sorry, index starts from 0, right? So 0, and this one, and then A2, and then A3, and then A4. This is the total 5 elements. These will be stored one after another. Okay, so if we can know address of any element in this array, we can find the address of any other element. Like suppose here, let's take this memory grid. The address of this memory location, let's consider it as 2000. Now, what will be the address of this element? This depends again on the size. Suppose let's take it as integer array. We know each integer value requires 4 bytes of memory. So after the 2000, 4 bytes is allocated for first element. So this first element address is 2000. So the second one will be 2004, and the third one will be 2008, and the fourth one will be 2012, and this will be 2016. Okay, so it's like an AP. Now how we can generalize it to a formula? First what we did, we had added the base address, that is equal to 2000 here, plus w, that is the size of each element that we are storing. Here the w is equal to 4. Okay, into how many times we multiplied this? 2 times. like this index is 2, this index is 0, this is 1 and 3, 4. Suppose we need to find this element address. So this I, and let's call it j. So j minus I, because it is a 0 indexed. If this is a 1 index, then we need to make it minus 1. Okay, so w into j minus 1. So that will be the formula, generalized formula. So address of ith element is equal to base address plus w, that is the size of each element in the array, and j minus I. Okay, sorry, this is I minus j, where j is the index of the base. Okay, here also I need to change. Now let's see the formula. Address of ai is equal to base plus w, that is the size of each element, and I, that is the index of the element which I am finding, and lb means index of this base address element. Okay, so index of element, base address, lower limit, storage size of one element. So let's take an example. Given the base array of an base address of an array a, where they are taking the index starts from 1300 to 1900 as 1020. I mean, the address of 1300 is given as 1020, and size of each element is 2 bytes. Here the w is given as 2. Find the address of a 1700. Okay, so lp is 1300 in that formula, w is 2 byte, and I is given as 1700. Now let's calculate it. Okay, the address of ai is equal to b plus w into I minus lb. This is the formula. And now substitute them. 1020 plus 2 into 1700 minus 1300. This is the index I that we are finding, and this is the index of base. Okay, and 1020 plus 2 into 400. Now that will comes out to be 1820. So this is the answer. Now let's talk about row measure order. This term came before. Now let's talk about it. What is row measure order? Uh, Suppose consider this two-dimensional array 1, 2, 3, 4, 5, 6. Now how these elements are stored in memory, it is like a contiguous block. It is not like a two-dimensional block. This will be stored in one single line only. How this will be stored? Um, we can store like this 1, 2, 3. I mean, first row, and then after this 4, 5, 6. Or we can also do first first column 1, 4, and then second column 2, 5, and then third column 3, 6. We can do in both of these ways, but in the memory it will be stored in row measure order. That is this thing. So what is row measure order? Now you might have understood. Row measure order means row after row. It assigns the successive elements moving across the rows and then down the next row to successive memory locations. In simple language, the elements of an array are being stored in a row-wise fashion. Okay, here this is one representation. Here ARR is, I mean, the number of rows are 2 and the number of columns are 3. So that's why first ARR 0, 0, 0, 1, 0, 2, and then 1, 0, 1, 1, and 1, 2. Okay, is what row measure order. Any question here or any doubts? Okay, I'm moving to column measure order. This also you might have understood by this. If the elements of an array are stored in column measure fashion means moving across the column and then to the next column, then it's in column measure order. Okay, so now we completed the calculating the address of first one dimensional array, and also we completed the row measure order and column measure order. Till this, any question, or is it fine? Okay, so seems like it no question, so I'm moving. We have seen how we can calculate the address of individual element in one dimensional array. Now the same thing for two dimensional array, but since there are two ways to store them, there are two formulas for two orders. This is for row measure order, and the next slide we will have a column measure order also. The formula is AIJ equal to base address plus W into I minus LR. LR is the index of the base address. This suppose this base address is 0, 0, then this LR will be 0 and this LC will be 0. If the base address that we know is 2, 3, then LR will be 2 and LC will be 3, like that. Okay, and now I is the index, I mean growth index of the element that we want, and there is also the second dimension. Okay, and now what about this n? N is the total number of columns. uh, let's understand this formula. Now suppose if I want the address of this fifth element, how I can find this, I mean how this is stored in memory. First these three elements will be stored, then only it will come to the second row, and this element also stored, and then it will store 5. So first, uh, suppose I need to find the address of an element which is in this ith row. I need to consider, I need to store all the rows that are before it. That means I need to store I minus 1 rows before. So that's why this I minus lr into n, this term came, and after it I came to this row, and before this element here I have one element, but it may be 2, 3 or any number. So for that, j minus lc. Okay, now this became a one dimensional array that we have seen before, so that same as j minus lc. Okay, now the terms explanation is given here. Now this is for column measure order. The what are the changes here? This n is changed to m, and these two are interchanged. That's all. And this I and j also interchanged. And the terms explanation remains as it is. So this is one example. Let's see how we can calculate this. We are given an array where this base is starts from 1, 1, and how many number of rows are there? 1 to 10. So total number of rows is m is equal to 10, and here n is equal to 15, and base value is 100. That means a11 is given as 100, and size of each element is 1 byte in the memory. This is w, right? Find the address of this element ARR86 with the help of row measure order and also the column measure order. Here I am just writing what are the values given. So let's see the calculation. Address of AIJ is this, and now we already have these values. So just substitute them, and you will get this answer, right? Again, the same thing. We are having the formula for column measure order. Uh, if we substitute these values, that comes out to be 157. Let's talk about time complexity of accessing individual element in array. How we can get the address of any element just by a formula like that mathematical calculation. So compiler stores the base address or the address of the first element of each array. Then when we access any element from it, it just uses that formula and calculates the address and code there and give the data to us. So Since that is a constant time operation, we can access the elements of array by using the constant time. Like the time complexity is order of 1 for accessing an element in the array. So till now we have seen how we can use arrays and storing the data in them. And suppose we have an array 3, 1, 5, 2, 6. Now we need to insert an element here. In the third position, I need to insert an element that is 10. So how we can do this? This array is stored in continuous blocks in memory, so we need to shift all these elements one bit right side, and then we need to store this 10. So this is what we can do inserting. Let's see the algorithm. First, get the element value which needs to be inserted, get the position where you need to insert, and check whether the position is valid or not. uh, that means if the position is given as -1 -2, that's invalid. So this position will be from 0 to this n minus 1. And if it is a valid, shift all the elements from the last index to position index by one position to the right, and insert the new element in the position. That means, so this is, suppose let's consider this is a position. Now we need to shift all the elements, start from here, move to this, and one bit. So move 6 one bit, 2 one bit, 5 one bit. Now store this new 10 here. Okay, this is what the algorithm. Otherwise, if the position is not valid, we can just say it is an invalid position. So this is a pictorial representation. Let's take an array of 5 integers, 120, 578, and 30. If we need to insert an element 100 at position 2, the execution will be, so these are the positions 0, 1, 2, 3, and 4. So first I shifted this 30. So 30 comes here, and then 78. 78 comes here. And we need to start from this, not from this. Okay. We need to start from very leftmost position, and we have to continue till this position. And 78 to this, 5 to this. Now, what will have? This will have 30. This will have 78. This will have 5. This is also will be having 5. Now we are stored, we can override this value to 100. This is the third step. So this is how the inserting algorithm works. This is a procedure, what we did. Now let's see the program of this insert. The insert function, n is the total size of array, and this is the element that we need to insert, and this is the position. Okay. First, I created for loop variable. This is just for this for loop, and I increased the size because we are adding another element. So I just increase the size, and then starting it from this n, I am moving till the position. I am just storing array I as array I minus 1. So just shifting, and then at finally array position is equal to x. We are completed. So return the array. Okay, this is the algorithm of insert. Let's see time complexity analysis of inserting. What will be the worst case? In worst case, we need to shift every element. Suppose,
Okay, Rajesh, there is a question
okay,
by Satvik.
right,
He's asking what is POS in the last example.
POS.
In the last example.
Okay, 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 okay. So suppose take this array like this, and now you want to insert 10 in position 2. What is the position 2? This is position 0, position 1, and position 2, 3, and 4. So this is the this position is the target index where we need to store this x. Okay, so we need to store this 10 here. For that, move this 8 first, and then move this 7, move this 6, and then override the 6. What will that become? 3, 5, 6, 6, 7, 8. Now this 6 is overwritten by the new value 10. Here position is 2, where we store this new value. Okay, I think this clears your question. Is this okay? Fine, right?
He hasn't written anything.
Okay,
Oh, yeah, he got it.
okay, fine. Now let's see the time complexity of inserting. In worst case, we need to traverse the whole array for inserting the element. So this is the 0 and this is 1. Let's take this array. Okay, I need to insert an new element at this position. So I need to shift all of them. If I want to insert an element to index 0, then we need to shift all the elements to the right. For example, if we have 5 elements in the array and need to insert an element in AR 0, we need to shift all those 5 elements one position to the right. So in general, let's generalize this. If we have n elements, we need to shift all the n elements. So worst case time complexity will be order of n. In average, we may need to shift 3 elements or 2 or 4, maybe. Suppose if we want to store the element in the last position, so there is no need to shift anything. So that is the best case. The best case is order of 1, because if the position value equals to the size, then there is no need to shift any element. You need to just append it to the end of the array. Okay, so the best case time complexity is order of 1. Okay, this order of 1 indicates that it is independent of the size of the array. How many elements if we have, it doesn't depend on that. Just we need to append it at the end. So now how we can delete an element? 3, 4, 5, 2, 6. Let's take this sample array, and I don't want this 5 here. I mean, I need to delete this 5. So the resultant array will look like this, right? How we can do this? This is the algorithm. Find the given element in the given array and note the index, because first we just want the 5 to be deleted. So first we need the position of it, right? Here the position is 2, but it may be anything. Search for it. If the element is found, shift all the elements from index plus 1 by 1 position to the left, where this is the index. So from this position, shift all the elements to the left. So move to like this, and 6 to like this. And also if we have extra elements, they also to left. Reduce the array size by 1. If the element is not found, then we can just print element not found, because there is no element to delete, right? This is an pictorial representation of the deleting. We here our goal is to delete this 20 from it. So move this 5 to the left, and 78, and then 30. Right. The resultant will look like this. Okay. So this will become 5. This will become 78. This will become 30. And now we just decrease the size of the array. That means if the size is n, we need to make n minus 1. Fine. Any questions in this delete? Is the just procedure what we did? Or let's move ahead to see the function. Okay, this is the delete element function, array, and the size, and the element we need to delete. First, search for x in the array, start from index 0 until n. If that is found, just break it. And now starting from this, if I is less than n, that means after this for loop ended, we come here. If there is no element x, then this I will be n, right? Then only this for loop will end. So if I is less than n, that means we found that element. If I is equal to n, then we don't have that element in the array. Okay. if I is less than n, reduce size of array and move all elements on space ahead. Okay, so n is equal to n minus 1, and then starting at this found index I till the n, arr j is equal to arr j plus 1. Okay, need to delete this 5. So what we do is first store 6 in this position, 4, 6, and then 7 in this position, 7 comes here, and 8 in this position. Here they 8, but we are decreasing the size, so this will be deleted. So our new array will be this. Okay. The time complexity of deleting. The worst case is also n, because uh, if the element which needs to be deleted is present at AR at 0, the same like before, if the element we need to delete is at the beginning, we need to shift all the elements from index 1 to size minus 1 by position to the left. Like here, suppose if we want to delete this A0, we need to shift this A1, A2, A3, and A4. That means all the elements except this A0. So it will take n minus 1 iterations. For example, if the array has 100 elements, the for loop will work 99 times. Hence the time complexity will be order of n minus 1. So we can ignore this minus 1. So we can say the worst case time complexity is linear or order of n, where n is the number of elements in the array. Now the best case is if we are asked to delete the last element, just we can decrease the size. If the element present at the last index, then below for loop will not work. Like the for loop in that function will not work. So we just reduce the array size by 1. It will take constant time, hence the time complexity will be order of 1. So finally, the searching of an element. This is also called as linear search. The algorithm iterate the array using the loop, check the given key. That means the element we want to find is present or not in the array. That means if the any element is equal to key, then we print the search found or just print search not found. Here, let's take an array of 5 elements, and our search element is 100. Our key is 100. How the execution will be? First, compare 35 and 100. It's not equal. And again, go to 2. It's not equal. Go to 23. It's not equal. 100. We found it. So we just break the for loop there and we print 100 is found. Or if we want to find 50, 100 is also not there, so 60. 100 is also not equal, I mean 60 is not equal to 50, so we reach the end of the array, but we didn't found that 50, so we just print search not found. Okay, this is how the searching this procedure. 34 is not equal to 100, move to next element, and so on. So let's see the function of this linear search array. This is the size and the key we need to search for it. Array, I mean for loop index variable I is equal to 0 to I less than n, I plus plus. We are iterating through the array. If any of the element becomes x, then just returning that index. Otherwise, we are returning minus 1. So this is how the searching algorithm. What will be the time complexity for first case? If the key is present in the last, that means ARR n minus 1 index, then the for loop will work n times because we found the element at the last. So, or even if we don't have that key in the for loop, it has to check for all the elements, right? So then also it works n times. Hence, the time complexity of searching in the worst case is order of n. Best case will be constant time, because if the first element is the key that we are searching, so it just work. The for loop executes only one time, so the for loop will break after its first iteration. That's why the best case time complexity is constant. So some problems for your practice, that is just I just explain the questions and give it to strings. Given a zero based permutation, build an array answer of same length where answer I is the nums of nums I. So we are given a permutation. Like what is the permutation? A permutation of size n means it consists of all the numbers which are from 1 to n. But here they are saying zero based permutation. That means it will have 0 to n minus 1. Suppose the permutation of length 5, it will have 0, 1, 2, 3, 4 in the array somewhere, but not in this order. Okay. Build an array answer of same length where answer I is equal to nums of 5 for each index. Now here the definition of a permutation is given. You can try this, and this is a sample input output. Okay, the explanation also there. The first element is the nums of num0. Num0 is 0, and again num0 is 0. So that's why this. And nums1 is 2. Now this will become nums2. What is nums2? So that is 1. Right. So in this way, this array is built. You can write out. The answer will be this. And second question, there are n kids with candies. You are given an integer array candies where each candies I represent the number of candies the ith kid has and an integer extra candies. Okay. Now the question is the number of candies the ith denote return a boolean array result of length n where result I is true if after giving the ith kid all the extra candies they will have the greatest number of candies among all the kids or false otherwise. Okay, let's see the this sample test case so we can understand. This is the input candies and extra candies is 3. If 3 is given all to the first one, now the number of candies at the first person will become 2 plus 3, 5. So this 5 is a greater, I mean the greatest or maximum. So this is true. If we give 3 to this, so 3 plus 3, 6. That's why this is also true. And 5 plus 3, 8. 8 is also maximum. So this is also true. And 1 plus 3 is 4, but 5 is maximum. So that's why this is false. And 3 plus 3 is 6. So this is true. If you have all extra candies, I mean, this is the explanation, right? So try these questions. And now I request Devanshu to take over for the strings. Or before that, do you have any questions from these problems or maybe anything? Okay,
Okay, I think no questions.
okay.
Okay, so I'll present my screen and let's start with strings and string functions. Although a lot of things will be carried over from the arrays as we saw just now. So, okay, so I'm Devanshu Chatterjee from IT second year, and I'll be covering strings and string functions in C++. And also, there is a bonus section at the end. So, if the class remains kind of interactive, I'll cover that as well. So, let's just begin. So for strings, I'll be telling you all how the strings is implemented in C++. The It is like an object of the string class, the string data type, and how the strings are stored in memory, different methods of taking input, functions, and operators that come along with the string object. A few code examples, very simple ones, and this one, if time permits, and if you all are interactive. So, what is a string and why do we need it? So, string is a very fundamental data type which all of us need because uh, any kind of data you want to store, it's mostly a string. Your name is a string, your address is a string. So, what is a string basically? It's any sequence of characters, right? Any sequence of characters. It can be alphabets, it can be digits, it can be special characters, it can be spaces. These all are strings, right? And to how do we represent a string? A string is basically any sequence of characters inside double quotes, right? So for string, we need to sh- always enclose the sequence of characters in double quotes. For C++ or like to understand, for the compiler to understand, it's a string. So a string variable, whenever we create a string variable, it's an object of the string class. So the string class, and the string class is defined inside the string library. So before we can use the string data type in our program, we need to include the string library or the C string library. These two, both of them will work. You can import either one of these. And the string library also provides a lot of inbuilt functions for different kinds of operations on the string variables, right? So like if you want to, we'll see what kind of functions are available. So let's just discuss how is a string variable stored. So a string, a string variable or a string object is stored in the form of a character array, right? As Rajesh discussed just now about arrays. So a string is an array of char data type. So like all kinds of operations are performed in very similar way as we do it in arrays. However, we have we generally have some inbuilt or predefined functions in the string library, which will help us to perform those functions, right? Those operations. And the string class, along with creating this character array, it also handles like dynamic memory allocation and termination, which means that the ending of the string, because a string is a character array. However, like we can store any characters, any number of characters in the string, but the string has to end at some point. So for the compiler to understand that the string has ended in memory, we use this null character, this forward slash zero, right? So uh, this is the null character, and whenever the compiler finds this character, it understands that the string has ended. So each character is stored as its ASCII value in memory. So like this you can understand also. Uh, I'll show here as well. So basically, I have written here code IIEST, right? So what we can see here, like this is capital C, right? So this has an ASCII value, right? So this ASCII value is stored in memory in this cell, some ASCII value. So like similarly for these, all these, right? However, uh, this null character is not for us, right? This null character is only for the compiler to see, and when we work with strings, this null character is generally ignored because this represents the end of the string. So we don't consider it. We will just see code IIEST only till 8th index as our string. This ninth index is ignored. So this is something that we must keep in mind. And like here you can see in this image as well that it's written hello, and then there is a null character, but this null character is not for us. It's just for the compiler to understand that the string is ended here, right? So why do we use string objects? Why don't we use a character array and store our string data in that? So there is a lot of advantage in using the string class, the string object. The advantages are that string data type makes use of dynamic memory allocation, so we are not wasting any kind of memory. If we use a character array, it has like it occupies a fixed amount of memory, and you cannot change it whenever you wish, right? So like if you are declaring a character array of size 10, so you cannot store any kind of word which is longer than 10 letters. However, if you are using a string object, you can change the size of word, you can add more words, and it will automatically adjust the amount of memory it is taking. And the string object will automatically terminate with the null character. So, like if we see here, uh, like this is our string, right? And let's say this is this is a character array. Okay, and we have declared a character array of size, let's say more than 9. Let's say it's longer than 9. uh, 10. I'll add one more cell. Right, now we have created a character array of size like 11. Okay, but we have stored a word of size 9, as you can see that, because it's zero based indexing and it's ending at 8. So these two cells are empty, and what the compiler will do is that fill these two cells with some garbage value. These two cells will be filled with some garbage value. So when we try to print this character array, if we try to print this character array, we'll get some output like code IIEST and like um, so we'll get some output like code IIEST and some random symbols, two or three symbols along with that. So this will happen when we are using a character array, right? But when we are using string object, what it will do is when we say that string s equals code IST, it will automatically add this null character at end to show that the string has ended. So when we use this string, we will not get those random symbols along with that. And along with that, like apart from that, like we'll get these inbuilt functions, which we'll not get with character arrays. So obviously use string data types. Now, how can we initialize a string? So there are two ways to initialize a string. I won't call it two ways, but yeah, because string is a class, it comes with constructors, right? Because whenever we create an object of a class, we call the constructor, right? So as you can see, using these braces, we are calling different constructors of the string class. So as you can see that all these constructors have different kind of purpose. Like this is an empty string, right? This s0, and we call this constructor, and we are passing a string data in double quotes. So s0 will be equal to this value. Now string s2 equals s0. Now we have created s0 already. So what it will do is this constructor will create s2 as a copy of s0, right? So now S3, as you can see, like it has something more, right? So what are these? So what are these? Like I'll explain. So S0, as we have seen, is initial string. This is the value. Now 8 means starting position, from where S3 will start filling. Okay, so if we count 1, 2, 3, from 0, 0, 3, 4, 5, 6, 7, 8. Right. So from S, it will start filling and it will fill for three characters. So it will fill STR, right? So the value of S3 will be STR. Like, is this part clear, or should I tell again? Like S0 has already has some value, and 8 is the starting position, right? So it will start at here at S, which is the starting position, which is the eighth position, and it will count three characters from here, 1, 2, 3, and it will fill in S3. So S3 will be equal to STR. Now S4 is equal to again a character sequence it's written, so like it will similar to S0. Now S5, this is written 10, and here is a single character. So what this constructor will do is fill this single character 10 times in S5. As you can see, 10 times x, S5 is this is the value of S5. This is another constructor like 10 and 42. So what it will do is convert 42 to a star. It will convert 42 to a star. So basically 42 is the ASCII value for star. So it will S6 will have 10 stars as its value. 10 times star symbol. Now, this is using constructors. We can also create strings using equal to operator or the assignment operator. So what we can do is we can create like two variables, str1, str2, and then we can use equal to for like assignment. And as you can see that we can assign str2 equals to a character as well. A character can go into a string, but there is a catch here. Like if I show you, like is this code visible? Like I think it's visible. So there is a catch here. If we create a string variable s1 and s2 and then declare it with a character, it's valid. Okay, as you can see, this code will run properly. It is giving me x. Okay. However, if I try it like this, if I try it like this, it will show me an error. As you can see, it's showing me an error because string s2 cannot directly take character because it doesn't have any constructor defined which can take a character. As you can see, there is no constructor defined which can take a character. Every all the constructors are taking strings except this one, which is a different kind. This is a fill constructor. It is filling characters. It is not taking any single character and assigning it to a string. So that is why this is valid, but this is not valid. This thing is not valid. Right, so this is the two ways of initializing a string. Now taking string as input. Now for taking input there are two ways, right? One is using the getLine function. The getLine function is defined in IO stream, so we don't need to do anything for getLine. And another is using cin. So now there is a difference between these two. So if we take input using getLine, it will read the entire line till a new line character is found, right? So if I'm giving this input, like see there is a space involved, right? So this is a name. I can even give a sentence with two or three words. Now getLine will what will do, getLine will read the entire sentence. So the value of full name will be this. However, if I use cin, it will stop reading after it finds the first space. Okay, so it will stop reading after then. It won't read the next word. So this is what will happen. So this is the difference between cin and getLine. And so in different situations, let's say you want to take an address as an input. So you need to use getLine. Cin will not work because it will read only one word. So that's the difference. Okay, so now let's begin with functions. Like, is there any doubt till now? Anything anybody wants to ask? Okay, so functions in string class. Let's just start with functions. So these are the functions that I'll be covering. There are a lot more functions. I have attached some references which you all can see later and have a look at all the different functions available. So the string class provides all these inbuilt functions, and we can access all these functions using any string object or a variable and putting a dot after it. So if I put a dot after this, let's say I have S1, so I put a dot after S1 and you can see all the functions that are available, right? You can see there are a lot of functions that cannot be covered possibly in such a short amount of time. So we're covering a few important ones, and these functions are implemented with optimal time complexities. They maintain memory allocation problems and also string termination standards. So if you are using these functions and you are using valid arguments, these will work perfectly. Otherwise you will get an error that this is happening. Okay, so first is the length function. So length function is simple. It does as it says. It returns the length of the string variable, and the return type is an integer. So I have a string here, code IIEST, and in del, if I put s dot length, so it will return me 9. And empty is a simple function. It does as it says. The function tells whether the string is empty or not. So the return type is boolean. As you can see, I have used the empty function with an if statement, and it will do accordingly. So the string s is not empty, so it will print string is not empty. Okay, now here is an interesting thing. So uh, this is an add. This is the add function which is implemented inside the string class, and this is the square bracket operator, right? So as we have seen with arrays, how we access arrays using the square brackets, right? We can just put the array name, then use the square brackets and put the index, and it will return the value at that index, right? And similarly, this add function also works. So if we do s dot add 2, so it will return me 2, right? So as you can see at position 2, I have D, so it is returning me D, right? Same is for this square bracket operator. So it will return me at s at 2. If I do this s at 2, it will return me D. So what's the difference? The square bracket operator is faster than add. Now, what is add? Why is it slow? So it is slow because this function has a fail-safe mechanism. So it will check every time that if the given index is valid or not. So let's say if I'm giving s at let's say this is a 9-letter word, but I'm giving s at 100. So s dot at 100, this will throw an error. It will cause the program to stop running. But if I do s at 100, this will not cause an error. In some compilers, it will just return garbage values, and in some compilers, it will cause a runtime error. So it depends. Like this square bracket operator is not fail safe. It just has an undefined behavior. So like on some compilers, it returns a garbage value, any random symbol or character it will return you. And in some compilers, it will cause error. But add always will give an error for every compiler, right? So that is the difference between these two. And because add is performing these checks, it is slower than square bracket operator, and both of them return type is char. So generally this square bracket operator is used. uh, then there is clear and erase. Now clear clear will do like completely, it will remove everything from the string. Okay, so if string has no matter what is the size of the string, whatever the string has, even if the string is empty, clear will just erase everything from the string. So if I like call s dot erase and then do c out s, I will not get anything, like it's empty. Erase function on the other hand, it is used to erase a part of the string and reduce its length. Okay, and erase returns the shorter string. Like after erasing a part, it will return the new shorter string. It will dynamically allocate reduced memory and return the shorter string. Now erase works similar to deletion in array. So erase has linear time complexity, but clear has constant time complexity. It doesn't have linear. It will simply delete the block. It simply deletes the block of memory. So it has constant time, but erase has linear time because it will remove the letters and then shift the remaining letters behind, like as Rajesh has explained already. So if I am deleting, let's say I am deleting this E. So what it will do is it will remove this E from here and shift all these backward by one place. Right? It will do for all the letters. So this has linear time complexity, but erase the clear function doesn't have linear time complexity. So like and there are multiple ways of using erase. So if I do s dot erase without any arguments, it will clear the entire string. However, This is linear time complexity, and this is oh, I've written here as well, but this one is constant. Okay, so this is the difference. And then s dot erase, if I say 4, so this 4 is the position from where it will start erasing. Okay, so as I've given 4, as you can see that this position is 4, so it will erase everything from 4 till the end, till the end of the string. As you can see, it just gives code. It has erased this part. Now there is another way, 2 comma 5. So what this will do is it will start at position 2 and erase 5 characters, right? Okay, so this will start at position 2 and it will erase 5 characters. 5. As you can see that it will erase this part. So my final string will be CO and ST. So as you can see, like this will be the output. So it will start at 2 and clear 5 characters from 2. I think like anybody has doubts or anything, like people can write yes or no anything. Hmm.
I think no questions. Yeah, no doubts.
Yeah, no doubts. Okay, okay, cool. So next is append and plus operator. So these work very similar. Like the append function is the primary thing which you should use for like appending characters or anything, appending strings. And plus operator is basically defined in the C like string library. The plus operator basically uses the append function only. So there is no difference between these two. They work similarly. So but yeah, like one difference that you will always find is that append will not work with characters again. So if I write something like s1 dot append and I give a character like x, so this will not work, right? But if let's say that I write something like s3 is equal to s1 plus x, so this will work. So what will happen is this will do automatic type conversion, right? It will convert this character to a string and then append it. So this is the advantage that you will get with the plus operator, but not with like append function. So append function, it appends the characters to the end of the original string and increases the length of the string. So there are multiple ways to use append. So like I have two strings here. So s1 dot append s2. So this will directly join these two and give me this output. Uh, then s1 dot append s2 2 comma 3. Now what this is doing is that okay, so I'll explain this one. Okay, so what this is doing, so so yeah, what was the s2 2 comma 3. So what this is doing is it will start at 2 and it will append 3 characters from there. So it will start at 2 and append 2, 3, and 4. So as you can see that it is giving code and then it is starting at E and appending then 3 characters, EST. So this will be the new value of S1. This is S1 dot append directly, it will append whatever is given here. Now this is S1 dot append, this is a string given and this is 3, which means that it will fill the first 3 characters from this string into S1. So like, can anyone tell me what will be the output? What will be the new value of S1? This string and the first 3 characters of this string get appended to S1. Can anybody type in the chat box? What will be the new value of S1? No, new value of S1. This is what will get appended. Mm-hmm. Okay. So Dev has here like this is the correct answer. So code IIE will be the new value of S1. See, S1 is already code, right? Now what this append function is doing is I have given it IIEST and I have told that append three characters from IIEST. So it will append the first three characters it will find, that is IIE. So this will be the new value of S1. Now this one S1 dot append 10, and this is a character given. So this is similar as we have seen before. So what this will do, like can anybody tell me what this will do? We have seen this before, this kind of. Yep, exactly. So it will do code and 10 times star. It will append 10 stars after code. That is what it will do. And this is the plus operator. Very simple. It will just uh, similar working, but it will just automatically, what it does is just automatically type converts the characters to strings as well. So append can't do that. So generally we use the plus operator because the plus operator basically calls append function only. So they are same. But the plus operator, like the order, how we understand the order of append. So like as you can see, if I do S1 dot append S2, so code is coming first and then IIEST, right? But if I write it like that, if I write it like this, if I write it like this, the output will change. So this will be IIST first and then it will come code. And similar is for the plus operator. So if what I'm writing here, this will give me this output. But if I change the order, the output will also change. So the order matters for plus operator. So for the plus operator, the order is important, and even for the append. So the part, the string which we need to put first, we use that, and using that we call the append function for other part of the string. Okay, so now comes substring and insert. So sub str, or what we call it, the substring function. So what it does, it creates a new string object with a copy of substring of the current object and returns it. So basically what it does is we have a string s and this is the value. Now I say that I want a substring of this string, which means that I want a part of this string as my new value, right? So this function will help me do it. This function will help me do it. It will return me a part of this string, and and in the arguments I can specify which part of the string I want. So the first argument is the position from where the cutting will start. The slicing will start from this position, and it will slice for these many characters. So so uh, Okay, so what's the example? S dot substr 4 and 5, right? So it will start at 4. This substring function will start at 4 and it will slice 5 characters. So 1, 2, 3, 4, 5. It will slice this part. But slicing doesn't mean that the original string will change. It will create a copy, as I've written. It creates a copy of of the substring, right? So this will create a copy. So S will remain same, but SS will now become IIEST. And this is a copy. So the original string doesn't change. Now, like I hope it's clear. Like this substring is one of the most like useful functions when it comes to string manipulation. So I hope substring is clear. And one more thing which is important for substring is that it will start at position, and it will uh, cut these many characters, this it will copy these many characters, or it will copy until the end of string is reached. Okay, so if as I have written here 5, but if I enter here 10, so what it will do, it will still return me IIEST, because after I after T there is nothing else in the string. So this is like important. Okay, so uh, whichever comes first basically. So substring formation begins at POS, which is the first argument, and spans length of characters, which is the second argument, or until the end of string, whichever comes first. Now, insert. This insert function, it basically inserts characters before the position indicated by user, as we have seen, as we saw just now, Rajesh explained us, inserting a value in an array. And what it does is, after inserting the new value, it returns the extended string. Because when we are inserting any new value, the string of like the length of the string will definitely increase. So insert function can also throw an error if the length of string is more than maximum possible. So let's say you have very less RAM, and you already have a very long string, and you insert more words into it, or more characters into it. So it will cause an overflow. So in that case, this will return an error. Okay, so s1 dot insert, this is the position at which insertion will begin. Okay, so if I count 0, 1, 2, so D is at position 2, right? D is at position 2, and at position 2, I want to insert S2, which means I want to insert B space C, right? So what will happen is that insert starts working before the given position. So if I'm given D, it will start working at position 1. So basically, the output for this will be A space. Now it will insert B space C, and like this is my string 2, right? This is my string 2. Can anybody tell me what will come after this? Yeah, like Satvik. Yep. See, this is the issue with insert, or this is how insert works. Is that I have mentioned I want position 2, right? But it will insert at this place.
But D is at person one. Okay,
No,
that is space. Okay, sorry.
yeah, because there is a space, right? So 0, 1, 2. So D is at position 2. And I have mentioned their position 2. So it will insert at this place where the space is. So the new string will become A, B, C, D, E. This will be the new string. Like, is this part clear? Like, if you can see, I have highlighted B space C. Now, if you can see that A space D space E, if I remove this part, you can see that I'm getting S1, right? Like, I hope this is clear, like the visualization is clear, how it's working. It has inserted S2 at position 2. As you can see that S2 is now at position 2. In place of D, I have S2, right? Okay, cool. Next is find. So find, it does what it says. So it searches the string for the first occurrence of given sequence of characters and returns the index of first character of first match. Okay, so as you can see, I have taken this example. There are two needles in this haystack with needles, and I want to search needle. Okay, so there are two matches here. Like, two times it will find this string needle. One is here, okay, and one is here. There are two matches. Now, when I run str dot find str2, it will return me this position. It will return me this position, which is the index of first character of first match. This is the first match, right? This is the first match, and this is the index of first character, which is 14. So this will be my output if I run this. Now, similarly, if I find str.find haystack, so haystack is at 30th position. So it is 30 is the index of h. Okay, and similarly, we can str.find, we can even put one character and it will give us the position of that character, which is 51 here at the end. So we can specify POS. We can specify POS to begin our search from. So like if we mention here, like this, on running this, it will give us like it will give us like n, this n. But if we mention that no, I don't start from this position, start from somewhere here. Okay, so I mention position 18. Now I give str2. So it will now start from position 18, and now it will return the index of this end, because this is the first match it will find when going from this position. So this is how this find will work. Now, like if find function doesn't it doesn't get any matches in the string, so what it will do is it will return us this thing, string colon colon n pos. Now what is this n pos? N pos is basically a constant. It is a constant value defined inside the string library, and the value of this is equal to -1. Okay, so the value of this is -1. So basically, if find doesn't get any matches, it will return us -1, or what we formally call it is string n pos. So like we can check if it found or not. So if found is not equal to string and pause, then it means that it has found any match. It has found some kind of match in the string. So that is how we put it in an if statement. Now replace. Replace basically replaces a portion of the string by new characters as specified in arguments. Okay, so it modifies the current object, and there are multiple ways to use based on the arguments passed. So I've explained here along with examples. So like this is a test string. So basically what it does is base is this. Now I do a dot replace, and now for a basic replace, I need to mention where to start. Okay, the first argument is where to start. Second argument is how many letters or how many characters to replace. So I'm starting at ninth position. So basically this is the position I'm starting at. So I'll start at this position and I'll replace 5 characters. I'll replace this part of the string. And what I will put here is n example. So as you can see that if you check these two strings, you can see that uh, space and test is replaced by n example, which is str2. So all these like all these functions have linear complexity: insert, find, replace. All of these are linear complexity because what it does is it is removing a set of characters and then inserting new characters and then shifting the remaining string. So this is all linear time complexity. And like similarly, these will also work. This is the starting position. This is number of characters to replace. This is like what to fill in, and this is additional arguments means it is taking out a substring of str3 as well. So it is starting from position 7 in str3, and it is taking 6 letters. So it is just taking phrase and not it is ignoring this sample and space. So like this is how we can customize a replace function as well to do more than one job. So like it is also taking out a substring and also replacing it. Like similarly this, it will start at 8, replace 10 letters and put just a. uh, like this one, it will start at 8, replace 6 characters, put a shorty, but it will fill just the first 7 letters from a shorty. So it will just fill this part. It will just fill this part, the first 7 characters. Now this is also very simple. It will start at 22, replace one character and fill exclamation mark 3 times, as you saw before. uh, this kind of thing, it's doing it here as well, right? So it is starting at 22, replacing one character and putting 3 exclamation marks. So as you can see that is this full stop is replaced by 3 exclamation marks here. So this is what replace function does. Now compare, very important function, compare, because whenever you are can have such that we can get all the index for the similar substring. Yep, you can do that. Yep, you can do that. So what you can do is basically like you select the substring, you select which substring you want. Like for this example, let's say I want re, right? I want re. So what I can do is I will do str dot find re, so which will give me the position of this r. Okay. Now the next time when I run find, what I will do is I will tell it to start from found plus one. Okay, so the next time it will do find, it will not give me this because it is starting from this position now. So next time it will return me this. Okay. Now again I will run this loop and I will tell it to start it from found plus one. So it will again start from here and it will look for the next IE which is not there. So the loop can end. So we can like code it that way, right? Did you get it? Yeah. So like find, basically what we are doing is we are telling that okay, you found first time here, so now start from one position ahead. So now it will give us the second or third or whichever it is. So this is replace, this is compare. Okay, so compare. Basically what it does, it compares two string objects and returns an int value indicating the relation between strings. Okay, so I have here two strings. One is green apple and second is red apple. Okay, now what I am doing is I am telling it to string one dot compare string two. So this is my string one and this is my string two. Now what compare does is that it goes okay. So it goes index wise. Let's say my string one is this code IIEST. Okay, and my second string is just code. Okay, so now what it will do is first it will compare this position of both strings and it will check their ASCII value. Now both are same. Okay, both are same. So it will go to next. Similarly, again, both are same. Till here, everything is same. Okay, now this position is filled. Okay, this position is filled, but for the second string, this position is empty. So what does it have? It has 0, right? So when it is comparing these two, when it is comparing these two, it will check the ASCII value of I, ASCII value of capital I, and what it will do is basically it will just do -0. Now it is finding a difference, right? Till now everything was 0 0 because C minus C, which is equal to 0. O minus O 0, D minus D 0, E minus E is 0. But I minus 0 is not 0. It will give us some positive value, right? So this time compare will tell us that okay, the strings are different and it will return us a positive value, which is the ASCII value of I. Okay, similarly, you can see here what it is doing. Green apple and red apple, it is comparing. So for the first place, it has G. in string 1 and it has R in string 2. So what is it doing? It is just doing G minus R. Okay, it is doing G minus R. So like it is giving because G is a smaller letter, G comes first, later comes R. So what it is doing, G has a smaller value and R has a greater value, so it is giving us minus 11, which is the difference between their ASCII values. That is what compare gives us. Okay, so it's giving us C minus 11, which means that string 1 is smaller than string 2. Now smaller here means that in a dictionary, if we put green and red, green apple and red apple in a dictionary, green apple will come first and red apple will come later. Okay, so this is what compare gives us. It checks the strings lexicographically, or what we say is if we put the strings in a dictionary, which string will come first. So if str1, uh, we will find str1 first, then it will give us negative value. If we will find string 1 later, like let's say if I switch this, then it will become plus 11. So this means that string 2 is greater than string 1, or string 2 will come later in a dictionary, right? And it will give us 0 when both strings are exactly same. So like if I just remove this part from these two strings, now they are exactly same, so it will give us 0. And this is also case sensitive. Okay, so this is case sensitive, so if I put a capital G here, so the output will change, because capital G has a different ASCII value. Capital G has a smaller ASCII value. So like if I do if I do small g and if I do it capital R, so what will happen is now this string will become smaller because the ASCII value is less. So yeah, that's what it does. Compare just goes like position wise it goes and checks. So these are the different things. Like similarly as we saw before, like string one dot compare and like 6 comma 5. So what it is doing is that basically this is mentioned for string one. Okay, so this means that uh, compare apple with string 1 and start comparing from position 6, which means this position, and go for 5 characters, which means this. So it will only compare apple from string 1 and this apple, which is equal, so it is giving us 0. And similarly for these two examples as well, like these are also different ways of calculating this apple part from string 2 and string 1. So see, this one is what it is doing. It is taking apple out from string 1, 6 5, and it is taking apple out from string 2, which is 4 5. So if you see that 0 1 2 3 4, so A is at fourth position and it is going for 5 characters. So A P P L E. So this is what it is comparing, apple here and apple here. So it is giving us 0 again. So is the like working of compare function is clear, how it's going, like it's going comparing position wise. Yeah. Okay, so let's see some code examples. These are very easy, like okay, so first is here I have given given any string, find the maximum character in that string. So here I have taken a random string. Now if you see, I have y as the maximum character, right? Because y comes later in a dictionary, so y is the maximum character here. Now how will I find it? Like, so first tell me, how will you go through the string? Like how will you iterate through the string? Check every character. Like, can anybody tell? Like let's say I have int uh, I equals to 0, because I'll begin at 0. Now I should be less than what? Because the string begins at 0, right? The string is beginning at 0. It's too messy now. Anyway, I'll see. I'll try to clear up this. Okay. So see, the string begins at 0, right? So we need to start checking from 0, and we need to go till this 4. So how do we get this 4? Anybody tell? Or I'll tell. Hmm. Okay, so I'll we can use string iterators. Yep, we can use iterators as well. And there is a simpler method too. Like what we can do is we can just take an int I equals 0, and I will go up to less than s dot length, and we will do plus plus I. So s dot length, what s dot end length returns, I have a string of size 5, right? This has a size of 5. So s dot length is returning me 5. And I'm telling the for loop to go less than 5, which means 4, because I is an integer. So it will go from 0, 1, 2, 3, and 4. So this will basically loop through the entire string. Right. So this can help us to go through the entire string character wise. Now, how will I compare if the uh, character is maximum or not? I have taken here char m equals to s of 0. I have assumed that the first character is maximum. Now what I will do is I will go through each of these characters and compare my current maximum. So if s at position I, what does it mean? That string s at position I is 0, then I is 1, then it will go at v, then it will go at w. Similarly, it will go. So if s at I is greater than m, then change my m, which means that s of I is the new maximum. So m is equal to s at I. I have changed my maximum. I have stored the new maximum I found. Right. So like this is I think this is clear. It's not uh, something very difficult. So as you can see that it's printing y. So this one is easy. Then given a string, capitalize all the letters. Okay, so this one we can do using iterators as well, but I'll keep it simple. I'll use this same thing again. Okay, now how can we do it? Like how do we know that our string is small letter or capital letter? Okay, first tell me, I want to take a sentence as input. So what should I use? Should I use scene or should I use something else?
Get lines.
Yep, exactly. So because I want a sentence, so I'll use get line, and I'll mention here cin, because cin is the source from where it will read the string, and I want to store it in s. So this is how we can use get line here. Now we want to check if each character uh, is a capital letter or what. Like if it's a small letter, we need to make it capital. Otherwise, we will leave it. We will leave the spaces alone. We will leave the symbols alone. So we don't need to do anything with that except for the small letters. So what we can do is make use of the ASCII values or make use of characters. So if s at I is greater than or equal to small a, and s at I is less than equal to small z, So this will mean that any character, any character which lies between small a and capital Z, because I'm going greater than capital A and greater than small a. So these many and then less than small z. So anything that lies between small a and small z, we want to convert it to a capital letter. So so now what we can do is just we can make use of the ASCII values. What we will do, we will say that okay, so this is a small
I
letter.
plus 26.
Yep. So it's 32 or something. Check it. Hey, what? I think it's 65, 96. I What's the ASCII values? Did I forget or something? I think it's 32, no?
It is 27.
I think I think it's 32. I'm not sure. Like I'll just check it. Like if anybody knows, then you can tell me.
After capital letters, we get smaller elements. Small letter means small a.
Like
There is nothing between the capitalized letters and the small letters in the ASCII value.
like yep.
I think it
It's
should be minus
97 and
26.
65. Okay, yeah. So I need to subtract. Yeah, I think 32 should work. Oh yeah, right. See, I'm such a noob. Okay, so I need to give some input, right? Okay, yeah. Such a noob mistake. Okay, so so what I'm doing is basically, yeah, I wrote it right. So what I'm doing is basically subtracting minus 32 because like the ASCII value of A is 97. I think, yeah, it's 97. And of capital A, it's 65. So the difference is 32. So what I'm doing is I'm subtracting minus 32. So if it's a small a, it gets converted to capital A. Now, if it's a small b, it will get converted to a capital B. So similarly for all other characters as well. So the same thing will happen. So this is like no matter what I give it as input, I'll put some symbols as well. Let's see what it does with symbols. So you can see that it leaves alone the symbol. So it will just convert these small letters into capital letters. So yeah. Okay, now this one, print the reverse of the given string. So this is I'm using scene because I need to take just one word. So I'll again use that uh, same way to loop through. But will this loop work? Can anybody tell me? Like, will this loop work if I want to reverse a string? Because what this loop is doing, it is going from 0 to n minus 1, right? It is going from 0, it is going this way, right? It is going this way. So will this loop work? Because I want to reverse the string. Can anybody tell what should we do otherwise? We want to reverse the traversal. Hmm. Okay. So I'll tell. So what we need to do is basically we need to travel in this way. So what we can do is instead of starting from 0, we can start at s dot length minus 1. So what we can do is make I as s dot length minus 1. So it will start at 4, and then we will make the condition as I greater than equal to 0, and then we'll decrease I as we go. So what this loop is doing, it is like traveling the string in this way, in this direction, and not in this. So I'll clear these things. So it is traveling in this direction. Now what I can do is I can just simply do a out and print the letters, print s at I, right? Or what we can do is we can store it in rev as well. So rev equals to rev plus s at I. So you can see that it is reversing. And also if you have noticed this, that plus, you can see that plus is allowing us to add a string and a character type, because s at I is a character. S of I is a character, and plus is allowing us to do this. But if I use an append here, it will not work. So if I do append s at I, so you can see that it's giving me error. This will not work. But if I use a plus operator, this will work fine. No errors. So this is the difference between append and plus. So let's just test it for more than one word and see the difference between seen and get line. So you can see that only this word was taken as input and it was reversed, but this was ignored. So that's the difference between seen and get line as well. So yeah, that's it for the coding examples, and we have time, I guess. Okay, so we do have some time. So let's just do the bonus section, which is the iterators. So as somebody already mentioned, we can use iterators for the strings. So yeah, this is the iterators. So an iterator is basically in C++, it's basically an object of that class for which the iterator is. So iterators are like class specific. There is a different iterator for string, different for a vector, or different for a list in C++. So it points to an element inside the character. So an iterator for a string will point inside a character inside the string. Okay, so there are different types of iterators, and all iterators don't support all types of iterators. So as you can see, like there are this Venn diagram kind of shows what type of iterators are possible. So instead of input output, I will say that these are read write iterators. So instead of input, it is a like it is a read iterator, and output is like the write operator. So then it's forward iterator is basically it can go in only one direction. It can only go forward, like it will start at 0, then go to 1, then 2, then 3, and its job is done. A bidirectional iterator can go forward and backward, like it can go from 0 to 1 and 1 to 0, like it can go in any direction. And a random access iterator, like it can start at any position then go to any position. So like a random access iterator, and basically I can say that bring me position 1, so it can bring me position 1. Then I can say bring me position 4, so it can jump here and bring me this. But the other two iterators, the bidirectional and forward, they cannot do this. They will always start at 0. And then when I say that bring me 1, so it can bring me 1, it can move forward and bring me 1. But if I say bring me 3, it cannot do that. It will go from 2, then 3, and then bring me 3. So these are limited. Okay, so and as you can see that forward can only move forward. So after it brings me 3, it cannot bring me 2, the forward iterator. But if it's a bidirectional iterator, it can go back and again like bring me 2 as well, bring this value as well. So that's the difference. Now, like for iterators, basically what we can do is basically we can get the iterators by using the begin and end functions for the object. So as you can see in this code snippet, I have written that like this is my string object. Now I have created an iterator. As you can see, I have used the string class and then created an iterator named b, and I have named it s.begin. And now for printing them, I must use this star symbol to dereference it because it's basically a pointer. If I print it directly, it will give me the memory address. But if I do star b, then it will print the value. It will print c. And the s dot begin will point at c. So I'll show this here. So what it does, the iterators. So s dot begin points at this location. This is my character array. This is my string, and s dot begin points here. Okay, but s dot end points here at this place. This. So if I try to print the value of s dot end, it will print some random thing. It will not print t. It will print some random thing. Right. So this is the difference. So this star e, this will print something random. I think it prints some a long number kind of thing, which is the memory address, and this will print us capital C. So like this is how we do using iterators. Now I can also show you the for loop using iterators. Mm, Let's do this one. Or I can just use auto. Auto it is equal to s dot begin while it is not equal to s dot end, and I'll do plus plus it. Now what I will do is rev plus star it. So let's just test it. Oh, wow, start begin. Start. Oh, I need to use the reverse loop. Sheesh. So how we do that? Okay, this will become complex, but so basically we use r begin and r end. Okay. So now you can see it is going DCBA. Basically r begin and r end. These are the okay. So as I saw, as I told you that iterator has a direction. Okay. So when I'm using s dot begin, like it is pointing in this direction, so it will go in this direction. So if I say plus plus s dot begin, so it will jump here. Now s dot r begin will begin at this position and it will go in this direction. Okay, it will go in this direction. So if I say plus plus r begin, it will go from 4 to 3. Okay, so that's the difference between an r begin and a normal begin. See, as you can see, like in the definition, it says that it is a reverse iterator. Okay, so I think, and as it's a pointer, so I'm using the star symbol to dereference the value.